This is the solution for the mock exam on descriptive statistics. Number 1, the mean of a population, x1, x2, blah, 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 x25 is m. Given that this expression is 300 and this expression is 625, find the value of m and the standard deviation of the population. This problem might be intimidating to you because of the sigma notation, which it's been a while since we've worked with it a little bit, and even back then maybe you weren't so sure about it. But just remember, the sigma notation is pretty easy. What it basically does is it tells you that it's going to take this expression here, and you're going to make 25 different versions of it in this case. Why 25? Because you're starting with the index 1 and you're going to the index 25. So what you're going to do is you're going to take the internal expression here and you're going to substitute in for I the indexes from 1 through 25. So like for the first one, I'll do the second one because it's a little bit more complicated. You're going to say, okay, the first expression is going to be x1 minus m. Second expression is going to be x2 minus m, etc. All the way to the last expression would be x25 minus m. Now, if you go back to the original definition, x1 to x25 is just ways of referring to each data value in the population, of which there's 25 values. Okay, so there's 25 numbers you're going to calculate on top of. Those 25 numbers can be any numbers. They're represented by x1, blah blah blah, to x25, and it doesn't tell you what the mean and the standard deviation are, but it does tell you that if you add all of the 25 numbers together, the sum of those numbers is 300, and that is related to mean, although it's not the mean. Now, if you take all the xi minus m's, which is, and remember the m is the mean, which you don't know yet, if you take each number, subtract the mean, square it, and add it together, you get 625, which is related to the standard deviation, although it is not the standard deviation. Now, how do you take these total sums and change them into the mean and the standard deviation? Well, if you remember the mean, the way you calculate the mean is you add up all these numbers and you divide it by 25, right? So, when you add up all the numbers, it's sigma x, right? And if you divide by 25, you are getting the mean. So 300 divided by 25 is the mean. Okay? So that's how we get the mean. How do we get the standard deviation? Well, remember that the standard deviation, if you look on the formula sheet, it's going to tell you something like this. I don't remember exactly what it looks like, but it kind of looks like this. Okay? So it's each data point minus the mean squared divided also by the total number of data values. And that is the standard deviation. If you remember, it's the sigma. Okay? So, and they don't tell us what each data point is, but they do tell us that the total, this top total, is 625. So we know that the standard deviation is 625 divided by 25. So these are things you can easily do on the calculator, right? 300 divided by 25 is 12. So the mean for this distribution is 12. And the standard deviation is going to be 25. Okay? All right. Number 2. A supermarket records the amount of money D spent by customers in their store during a busy period. The results are as follows. So on the top, they have the amount of money spent by each customer. And then on the bottom, they show the number of customers that spent that interval of money. Find an estimate for the mean amount of money spent by the customers, giving your answer to the nearest dollar. Okay, so we're going to use the calculator to do this, stat edit, of course. And when we put the data in the calculator, one of the questions you're going to ask yourself, which is something you're just going to have to memorize or get used to from doing problems, is what number do I put in column 1? Because they're not giving me one number here. They were giving me 0 to 20, and I cannot put interval 0 to 20 into the calculator. I need to choose a representative value. So I could choose 0 I could choose 20, or I could choose halfway in between, which would be 10. Well, in this case, the most representative value is the middle number, right? So what I'm going to do is I'm going to write down the mid-interval value for each one of these, the middle value, and that's the number I'm going to put into the calculator. So, first number is 10. Second number is 30, 50, 70, 90, 110, and last of all, 130. Okay, and then I'm going to put in the frequencies in column 2. 24, 16, 22, 40. Why am I doing this? Well, this is the first step to figuring out an estimated mean or an estimated standard deviation. Why is it an estimated mean or an estimated standard deviation instead of the exact mean or standard deviation? Here I'm going to do stat calc, one of our stats, of course. L1 and L2, it's already in there. Calculate. L2, of course, is the frequencies, the second set of data, and L1 is the first set of data. Okay, so it gives me a lot of interesting information here. X bar is the mean, okay, which is 58.7. Why isn't it estimated mean and not the real mean? Well, we're already starting out with data that is not like really precise. Why? Because we know that there are 24 people that spent between $0 and $20, but how many did person 1, how much did person 1 spend? How much did person 5 spend? How much did person 17 spend? How much did person 24 spend? We don't know. The only thing we know is that all those people spent an amount between 0 and 20. It could be that everybody spent $1 and the average is 1. It could be that everybody spent $20, the average is 20. But we don't know. So what do? We assume, for lack of better knowledge, we assume that the average would be 10. So what we do is we put the midpoint interval of 10 into the calculator, and that's going to represent that interval for us. And so the estimate for the mean is going to be 58.7. If we wanted to know the estimate of the standard deviation, we could use 32.5. Okay, but they didn't ask us that. All right, moving on. By the way, that's dollars. Complete the following cumulative frequency table and use it to draw a cumulative frequency graph on the grid following page. Sorry about the English there. Use a scale of 2 centimeters to represent $20 on the horizontal axis and 2 centimeters to represent 20 customers on the vertical axis. Okay, now they're being really nice to you here because they're not actually expecting you to remember how to make a cumulative frequency table, although pretty easy to remember, right? Okay, but they give you a hint here. Look at that. 24, 24, it's the same. The next one, wait a second, that's not 16. It is 16 plus 24. So do you see the pattern here? You are going to add up the numbers to get the cumulative frequency table. So this one, of course, is going to be 24 plus 16 plus 22, which is the next one. Okay? So how do we figure that out? We're just going to use the calculator and we're going to add up each one. So actually, instead of doing 24 plus 16 plus 22, we could just take 40 plus 22, right? We could add up these numbers. 40 plus 22, of course, is 62. Then we could add up 62 with this value here, 40. 62 plus 40 is going to be 102. Then we could add up 102 with 18, which would be 120. Then we could add up 120 with 10, which is 130. Now do you see why they call it a cumulative frequency table? 134. So the total is going to be 134. And if you add up all the numbers here, you should get a total of 134 anyway, right? Okay. Oops. All right. So we filled in the cumulative frequency table, and now we're going to use it to make a cumulative frequency graph. Now, I know you guys have a big challenge, which is dividing up the graph paper appropriately. On the IB exam, usually they're very specific about how to divide it up. Look at that. 2 centimeters to represent $20, 2 centimeters to represent 20 customers. So basically, it's easier if you think about it. It's like 1 centimeter for each $10, 1 centimeter for each 10 customers. Okay, and remember, the data goes on the horizontal, and the vertical is the frequency, or the number of people, or the number of exams, or whatever. So the maximum value for each one is easily found by looking at the last cell here. So $140 and 134 customers. So on the x-axis, we want to do 134 customers. Y-axis, $140. So we're going to go here to the graph paper, and we'll assume each one of these squares is like 1 centimeter. So we're going to do 140, 120, 100, 80, 60, 40, 20, and 10, and 0, sorry. Okay, we counted by 20s. That's kind of tricky. You forget halfway. And then here across, we're going to do 0, 20, 40, 60, 80, 100, 120, 140. No matter how obvious you think it is, you should always label. You should always label the intervals, and you should always label the axes. So the axes is like the D value, which is amount spent in dollars. And then on the y-axis, you could put cumulative frequency. Okay, and then the y-axis is always cumulative frequency, right? And then we're going to go through and we're going to plot each one of these cumulative frequency values here. And since we have done the addition, accumulating the numbers, you can always see that going along this table, you are increasing the values, right? And then that's why you know that if you simply put these numbers in, you're not going to be increasing. The middle is going to be higher, and the right side is going to be lower. You know you're not making a cumulative frequency graph, okay? So in this case, you know that you are, because the numbers are steadily increasing. That's what's supposed to happen. So first, 24, 40. Oh, wait a second. Where did I put the 24? Let's check. The 24 goes with the D of 20. So it's 20, 24, 40, 40. So I'm going to start graphing my points here. 20, 24 is about there. 40, 40 is there. 60, 62 here. I don't want to make you seasick by switching between the two screens, so I have the screens visible to me. You're just going to have to trust me that the numbers are how I say they are. 80, 102. 100, 120. And 120, 130. And 140, 134. Okay, and then what you're going to do is you are going to connect these points. Oh, and a point that we didn't talk about is 0, 0. So at the beginning of the first interval, you're going to mark it 0. Okay? You're going to draw a curve through these. You're not going to try to connect them with straight lines. If you connect them with straight lines, you're going to lose a point. So try to draw a smooth curve through them. Okay, and that's the last value here, the 134. Okay, now let's go back and see what we're going to do for the next step. Okay, now they're going to ask us something which is not really related to the cumulative frequency graph. They tell us that the time spent by the customers in the store can be represented by this equation. So it's like the time spent in the store can be calculated from the money spent in the store. D is the dollars spent in the store. So we're going to use this equation and the answer 58.7 from part A to figure out the mean time in minutes spent by the customers in the store. Okay, so that's this here. And so what we're going to do is we're going to take the average, or the mean found before, 58.7, okay, and we could put, since this is a dollar amount, we could put something a little bit more precise. We could put .66, because usually IB wants you to keep cents for the financial amounts. Okay, so we're going to put here 58.66 into this equation and see what we get out for t. So let's see. We'll put in 2 times 58.66 to the 2/3 power. Oh, we better put this in parentheses. 2/3. 2/3 power. And then plus 3. Let's see what time equals. It's equal to 33.17. 33.17. Okay. Minutes. Use this equation and you're probably blah, blah, blah. Okay, so we're going to put 33.17 minutes. Use this equation and the cumulative frequency graph to estimate the number of customers who spent more than 37 minutes in the store. 37 minutes in the store. Okay, we know that our graph only has dollars and frequency on it. So how's that related to 37 minutes? Well, we could use the equation to take the 37 minutes and change that into dollars. So let's say that t equals 37 minutes. Then what would the dollars be? So we're going to put 37 minutes is equal to 2 times d to the 2/3 plus 3. And then we're going to use algebra, subtract 3 from both sides. We get 34 equals 2d to the 2/3. Divide 2 both sides. We get 17. 17 equals d to the 2/3. And then we're going to use, then we're going to find what's the inverse of taking d to the 2/3? Well, it's taking both sides to the 3/2. 2/3, 3/2. You multiply these two, it gives you 1. So then you just have d is equal to 17 to the 3/2. You can find this here. D divided by 2. Yeah, I don't even need to put parentheses around it because they're both up there. 70.09. So the dollar amount is $70.09. Okay. But they want to know number of customers who spent more than 37 minutes in the store. Okay. So we just found out that the customers who spent 37 minutes or more in the store spent $70.09 in the store. Is it or more or less? Well, if you look at the relationship between dollars and time, you know that both increase. So more than number of customers who spent 37 minutes or more in the store, that means the number of customers who spent $70 or more in the store. So now when we go down to the graph, we find 37, or 70.09 dollars, right? It's right there. And then that is the critical value, but are we looking for values to the left or to the right? Well, we want people who spent more than 37 minutes in the store, so that means people who are on the right side of this critical line, right? People who spent more than $70. So then, when we go up to here and we cross the curve, we're going to draw a horizontal line to the right, and then we know that that corresponds to the people above this line. So that means we're talking about people who, like this person here looks like it's like the 82nd person maybe. And then it goes all the way up to the 134th person, right? And what are they asking for again? They're asking for number of customers who spent more than 37 minutes in the store. So that would be the 82nd person to the 134th person. So that would be about 134 minus 87, 82, which is about 52. And if you count the 82nd person and you count the 134th person inclusive, you would actually have to add one. That would be 52 people represented between the 82nd person and the 134th person. That's 52 people. So, or 53 people. Is that right? 53 people. So it would be 53 people. Okay? Alright, part D. given the exact minimum of the distribution is $5 and the exact maximum is $130, find the median and the lower and upper quartiles from the cumulative frequency graph. Then draw a box plot for the distribution on the grid below using a scale of 2 centimeters to represent $20 on the horizontal axis. Okay, so you're going to see why they did this a little bit later, but we will need these values later. But let's find the median and the lower and upper quartiles from the cumulative frequency graph. If you remember how to do that, you are going to take basically the middle person, which is 134 divided by 2, to get the median index. That would be, what would be 65 plus 2, 67 person. Okay, that would be the median. And then what about the upper quartile and the lower quartile? Also known as Q3 and Q1. So what are the indexes for Q3 and Q1? So it would be 134 times 1/4. That would be 134 times 1/4. So 33 and a half. So it would be about 34th person. And then for the upper quartile, it would be 34 times 134. It would be about the 100th person. Okay, so we were looking for the 67th person, the 100th person, and the 34th person. Since we're looking at people, then we're looking at this index here. Put it. Okay. So 34th person would be here. And when it hits the blue line, you go down, and then we get a value of about 32. So the 34th person corresponds to $32. The middle person is the 67th person. It's about here. And it hits about there. And you're going to be doing this with a ruler on the real exam. And this is going to be the 62nd, $62 about. That'll be the median. And then the 75th percentile, or the upper quartile, is going to be the 100th person, and that's it, the 100th person right there. Slightly to the left of this blue line. It's going to be about 79, let's say, $79. Okay, so we know that the first quartile is $32, the median is $62, and the third quartile is $79. They also told us that the real minimum is $5, which is right there, and the real maximum is $130, which is right there. Why did they tell us that? Because if you don't know that, you would automatically just put 140 and 0, but those aren't the real minimums and maximums, right? We don't know exactly what the real minimums and maximums are because they don't tell us that in the interval values. They're just buckets filled with frequencies, and we don't know what the actual smallest frequency or the highest value is. So, but when they do tell us the real numbers, we can use those. How do we use those? Now we're going to use those to make our frequency or our box plot. And the box plot is centered right at the median, which is the $62. You can just since we're using the exact same scale, you can just take these pink lines we've drawn and copy them down here. Draw vertical lines for the outlines of the box. And then complete the box like that. And then the minimum, which is $5, is right in the middle there, right? And you just draw a dot to represent the 5. You draw a dot to represent the 130, and you connect the box to the dots. And we've completed our box plot. If you want to, you could put the scale here, but since the scale is the exact same as before, it's pretty easy. Okay, and this is the D value, right? The amount spent.